In this video, we have been told to find the value of x. So x is from this point to this point, and they're telling us that the outer figure is a square. So this here is a square. And also don't forget to realize that this line is parallel to this line. Okay, that's a condition. They've told us this line is parallel to this line. And these angles are 90 degrees. This is 90 degrees. This is also 90 degrees. And this side, this length here of this line is √8, while this length is √2. So with that information, how do we find the value of x? Let's start by labeling our figure. Let this be M, N, O, P. Let this one be point Q, and this one R. Now we were told that RP is √8, but √8 can be simplified. This is the same as 8 is 4 times 2, which can be written as √4 times √2. Square root of 4 is 2, so 2 √2. So this side RP is equals to 2 √2. So if this side is √2 and this side is 2 √2, that implies that side RP is twice side RO. Next, let us extend this line MQ towards line RP. Just like that. Now, since this line NQ is parallel to line RP, now this here, MQ, is a transversal that cuts the two parallel lines NQ and RP. Therefore, the corresponding angles are equal. Okay, so if it formed, this transversal formed 90 degrees on this line, that implies that this also here is 90 degrees. Let me call this point here S. Also, let me extend this line OR to line NQ. Now, since we've already seen that NQ is parallel to PR, so also OR going all the way is also a transversal that is cutting two parallel lines. Therefore, the corresponding angles are equal. Therefore, if this transversal forms 90 degrees on this first line, therefore, it will also form 90 degrees on this line. So this is 90 degrees. Let me call this point T. So if this is 90 degrees, this will also be 90 degrees. Then this here will also be 90 degrees. Now we realize that these triangles here, this triangle MSP, so we have triangle MSP, also triangle NQM, also triangle PRO, and finally triangle OTN. We realize that they're all right triangles. So as you can see, this is 90 degrees here, this is 90 degrees, this is 90 degrees, this is 90 degrees. So this triangle, this triangle, this triangle, and this triangle are right triangles, right angle triangles. Now if we are to look at this triangle here, OTN, this one here, if we are to say this angle, if we are to call this angle alpha and this angle beta, and we already know that this here is 90 degrees, that implies that alpha and beta must also be equals or must add up to 90 degrees in order to make the total 180. So if alpha and beta add up to 90 degrees, that implies that alpha and beta are complementary angles. Okay, because they add up to 90 degrees. Now, since this here is a square, that implies that this angle is 90 degrees. And if it's 90 and this is alpha, we saw that beta is the complement of alpha. So this here will be beta. And since we see that here is 90 degrees and this is beta, so that implies that this will be alpha. Also, this is 90 degrees at this angle. So if this is alpha, this one will be beta. And we know that this angle is 90. So if this is beta, this will be alpha. And this angle here is 90 degrees. So if this is alpha, then this here will be beta. And we know that this is 90. So if this is beta, this angle will be alpha. Even without that, we know that this is 90 degrees. So if this is beta, this will be alpha. Now, since MPON is a square, that implies that all its sides are equal. So that means that MP is equals to MN, which is equals to NO, which is equals to PO. So since this side is equals to this side, which is equals to this side, which is equals to this side, so we can conclude and say this triangle here, NQM, and this triangle MSP, plus this triangle PRO, plus this triangle OTN, they are congruent. They are congruent triangles due to the angle side angle theorem. So as you can see, angle side angle, the same angle, same side, same angle, same angle, same side, same angle, same angle, same side, same angle. So they are congruent triangles. Now, since they are congruent triangles, if we are to look at this triangle PRO, we can see that this side is root 2, and it is the side that is opposite to angle beta. That implies that in all these congruent triangles, the side opposite to angle beta is root 2 for all of them. So we can see that in this one here, the side opposite to angle beta is this side here. So from N to T is root 2. Also, the side opposite to beta in this one is MQ. So MQ is root 2. Also, the side opposite to beta in this one is SP. So SP is root 2. Remember, this 2 root 2 is for the whole of RP. Don't get confused with that. So RP is 2 root 2. And we are saying just SP is root 2. Okay? And then we can see that the side opposite to alpha in this triangle is 2 root 2. So RP is 2 root 2. And that's the side opposite to alpha, implying that in all these congruent triangles, the side opposite to alpha is 2 root 2. So in this triangle, TO will be 2 root 2. Then in this triangle, with the side opposite is NQ, so it's 2 root 2. And then in this one, the side opposite to alpha is MS, so that is 2 root 2. So if we are to look at this triangle here, OTN, we can see that side OT is equals to OR plus RT. And we've seen that OT is 2 root 2. So 2 root 2 is equals to OR was given as root 2, so root 2 plus RT. So making RT the subject, this will be 2 root 2 minus root 2. And so RT will be, so since root 2 is common, we factor it out. We shall be left with 2 minus 1. So RT is equals to root 2. 2 minus 1 is 1. So 1 times root 2 is root 2. So RT from here to here is root 2. So if we are to repeat this process for the other congruent triangles, this one, and this one, we shall realize that these sides are all root 2. So from RT we've said is root 2. Also, TQ will also be root 2. QS will also be root 2. And RS will also be root 2. Now focusing on this triangle here, QTR, we can see it's a right angled triangle. This is 90 degrees, and this side QT is root 2, TR is root 2, and the hypotenuse QR, which is X, that we are required to find. So we're going to use the Pythagoras theorem to solve. So A squared plus B squared is equals to C squared. Our A is TR, which is root 2 squared, plus our B is QT, which is also root 2, is equals to our C, the hypotenuse, QR, which is X, so X squared. Therefore, X squared will be equals to, this cancels with a square root, this also cancels with a square root, so we are left with 2 plus 2, and so X squared is equals to 4. To get rid of this square, we shall find the square root on both sides. So X is equals to 2. We take only the positive root since X represents length, so it can't be negative. Therefore, we have been able to find the value of X, and it's 2 units. Okay, so QR is 2 units. Thank you so much for watching. Kindly subscribe to this channel if you haven't done so yet, because it's completely free of charge. Please subscribe. Thank you to those who have already subscribed. Then, if you enjoyed this video, kindly give it a like. And also, do not forget to comment your thoughts about the video in the comment section down below. Also, if you have alternative approaches, you can also share them with us. Otherwise, thank you so much. Let's meet in the next video.